able to understand? Oh, great. Okay, cool. Okay, so that was our first week in which we have learned about Linux, networking, a bit of automation, and that was the foundational week in which we have created out a foundation. And I can see that currently in our leaderboard, I can see folks are actually doing pretty good. So if I'll open up the leaderboard, Anil is in the top three. Anil, Yash, and Jamal are in the top three. These are the points that the candidates have received just from the labs. On the assignments, on the modules, we are going to re-verify everything by Sunday, and we are going to have one-on-one call with you in order to help you understand the gap and bridge the same gap. Okay. Now, with being said that, let's now move to our agenda of this call. That is going to be about a production outage that we have simulated in our war zone. We are going to uncover it, and we are going to jump into our actual war rooms in squad-based fashion. So I believe everyone has already got their squad names. If not, then you can drop out your name in the chat, and Sanket is going to help you with that. Okay. So let's now talk about our agenda of this call. So in this session, we are going to talk about a production outage from the very scratch. Since in the weekdays, we have explored the concepts of Linux networking automation. We have executed and troubleshooted a few of the outages by ourselves also. But while understanding how you approach towards the outage, that is very different. And in this session itself, we are going to learn about that strategy to approach an outage. What is an outage? What are the technicalities that is involved in an outage, and then how to fix out an outage? This is all the things that we are going to explore in this session. This is not going to be a simple K8 issue or those kind of things. So, Sanket. Yeah. So, in this session, we are going to explore out an outage that has actually happened in an organization called Cloudflare back in 2019. So, we will be exploring out that outage shortly. So, before jumping into the outage, I wanted to explain the overall call flow, how exactly we are going to move forward in this overall call. This is going to be 2 to 3 hours long call in which we are going to explore a lot of things. So at the very first, we are going to explain you today's mission. It is going to be about that Cloudflare outage that I have talked about. And then, as I have already mentioned, that all of you has been assigned to a certain squad. There are over three squads, squad alpha, beta, and gamma. And you'll be able to see your squad name on your dashboard. And you can opt as an subject matter expert who is going to have the read access of the overall infrastructure, and you can opt as an incident lead who is going to take the ownership of that infrastructure for that moment of time, and you are going to lead your team in that war room. There will be three different squad who are going to compete with each other in order to solve that outage first. Okay. And we are going to jump into an isolated room in which you'll be only able to communicate with your squad members, not the whole batch and all. Okay, now we are going to after that we are going to talk about the actual production outage. Now, before jumping into the problem statement, we are going to understand what is an outage, what are the types of outage, what is a blast radius, what is a timeline forensics, what are the categories of an outage, how to define a problem statement, why not to get started with logs. All of these technicalities we are going to understand before jumping into an outage. And then, after having a basic understanding of how exactly an outage works, how a normal system behaves and how an abnormal system behaves, then we are going to jump into a live outage in order to find out that difference between a normal behavior of a system and an abnormal behavior of a system. And this is going to be the Cloudflare outage that has happened back in 2019, which has impacted several organizations, and it has lasted close to 3 hours. So we are going to talk about that outage, and we are going to talk about what exactly happened, the business impact, the customer impact, and then we are going to talk about the timeline forensics of that outage. So in this outage, what exactly happened minute by minute? We have created out our own timeline forensics to give you an idea what exactly happened with the system and how the team was moving minute by minute. This is something that we are going to explore in the timeline forensics. And then after this, we are going to get into the actual production to give you the KT that you need in order to understand the whole infrastructure. I'll be giving you a KT of that whole infrastructure. I'll be walking you out throughout the whole infrastructure. With the help of terminal, we are going to understand the request flow, the services, the deployments, the networking, namespace, observability, all those kind of components that is involved in this infrastructure. Okay, and we are also going to share you some of the last minute tips that what to do, what not to do. And then after all this, we are going to jump into a live war room, squad by squad. You are going to join a live war room with your squad. And you, if you are acting as an incident commander, you are going to have the right or admin access of that infrastructure, and you are going to be someone who will be taking out the full ownership of the decisions that had been made throughout that call. And then this is going to be of 60 minutes in which we are going to help you as an individual instructor to help you understand the outage and fix out that outage. And then after an hour, we are again going to jump into our main call, and then we are going to share our experience that each of the squad are supposed to now share their experience of what was their hypothesis and what exactly they have done in order to find out the issue, or whether they have found the issue or not. And this is where we are going to learn most of the things, because it is going to be a collaborative learning. And then after all this, we are going to jump into the deep dive of that incident, where exactly we are going to talk about what exactly happened, why happened, everything. And then we are going to take you through a debugging playbook of this outage. So this is a category of outage that happens in most of the production ecosystem. So we are going to give you a debugging playbook that will be applicable for all those common outages that you are going to face in future. And then we are going to share our screen into a live resolution of this outage. And then from this outage, we are going to build out a resilient system that is going to make sure that this kind of outages doesn't happen in future. And then we are going to wrap the call by understanding what exactly is an RCA, what is an why exactly it is that much important, how to create an RCA, uh, what kind of five whys are there in that RCA that you need to integrate in order to create out a professional RCA that explains the situation even to a technical or a non-technical person. This is something that we are going to explore. And then at the last, we are going to talk about some good versus the bad RCA example of this outage. And we are going to close everything by giving you the similar production outages that you can practice in the upcoming days. So this is going to be our overall agenda of today's call. It can be that we have to extend this call from 2 to 3 hours, or if we'll be covering out most of the things by today, then it's good. Otherwise, we are going to extend out this call even to tomorrow to cover up all of the things that has been mentioned here as in the part of agenda. So this is about the agenda of today's call, and we are going to explore all this step by step. Now, let's now jump into the actual arena in order to understand what exactly is happening throughout the platform. Now, if you will get into the war zone, and if you will search here with the name of system reliable, you are going to see out an outage with the name of system recovery collapse. And if you'll click on filter by company, you are going to see out a logo of Cloudflare. Just click on this and you are going to see this outage. If you will click on this outage, you are going to see all the details of this outage. What is the current scenario? What is the current situation? what exactly is your objective, the constant that you don't have to do, the expected outcome, the investigation node, and everything. And here we have attached out some of the references, some of the resources that is going to help you understand that how exactly it is happening across the organization. So as you can see, this is an outage RCA that has been published by Cloudflare. So here is the link of that documentation. Apart from that, there is also link of few more documentation that I have attached. So there was a similar issue that has happened with Amazon S3 back in 2021. We have also attached that, and a Google SRE book chapter to understand this kind of outages in detail. Okay. Now, before actually jumping into the technicalities of this specific outage, we are going to get started with the basics of an outage. What exactly is an outage? How to understand an outage? How to define the problem statement? All of those technicalities that you need in order to troubleshoot this outage. And then we are going to jump into the actual outage. Now, let's get started with that. So, okay, now I'm going to present out the screen. Okay, so now let's now start with what exactly is an outage. So most of the people understand that if I have a pod crash, or if anything related to application or something, if overall anything is getting impacted, that is an outage. But we as an infrastructure engineers, it can be anyone like platform, SRE, DevOps, anyone. So we as an infrastructure engineer, for us outage means there is a service A and there is a service B, and service A is not able to communicate to service B. Now this is going to be the actual outage for the infrastructure engineer. So uh, if you hear the word outage, you need to understand who is not able to communicate to what. Now you need to create out a relation in order to understand what is the outage, what is the exact outage. Now let's suppose outages are of actually two kind: the application outage and the infra outage. And as I have already mentioned, that as an infrastructure engineer, we have to take care more on the infrastructure outages. And if you are someone who is having some enterprise applications in your infrastructure, so you also have to take care about those all application that is a part of your infrastructure, right? So outage doesn't mean if your pod is crashing, that is an outage. If it is a configuration issue, and if it is impacting the customers, then it can be treated as an outage, because the customers are not able to communicate to your system. So if you are going to define out an outage, it should define clearly that a system A is not able to communicate with the system B. And this is where we are going to define out the outage, what exactly is an outage. For an example, we have mentioned a few of the examples out there that are checkout service in an e-commerce application. Let's suppose if we have an organization like Meesho, Flipkart, the checkout microservice is not able to call out the payment microservice. Now a system A is not able to call out the system B. Now this is going to be considered as an outage for the infrastructure engineer. And similarly, our microservice is not able to reach out to the database. Now that is a downstream problem, but still our services are not able to communicate with each other. That is also going to considered as an outage. Now our pods are not able to communicate to an API. That is also going to be considered as an outage. But the pod crashing is not an outage, right? Um, Now, apart from that outage, you also have to understand the blast radius of an outage, that your outage has impacted which kind of systems, which kind of customers, how much of finances. You also need to understand all of those things. Now, blast radius are basically, there are two kind of blast radius of an outage. The first one is going to be internal blast radius, in which the production outage is going to impact the internal productivity of a engineering team. For an example, there is a something that has happened with my sit environment, PPT environment, dev environment. Now this is going to impact the internal productivity of my engineering team. So that will be a production outage with an internal blast radius. Now, the other kind of blast radius of an outage is going to be the external, that is having the severity as red one. Now, this is an outage that is P0, okay, and this is something that is impacting the customers directly. Now, if because of something in our infrastructure, if the customers are getting impacted, then it is going to be considered as an external blast radius outage that is going to cost a lot to an organization in terms of finances, in terms of reputation of that organization also. So if it is an internal blast radius outage, you are going to have some bandwidth to solve that out. If it is external blast radius, it is going to impact a million of customers, and we are only going to talk about those all in outages that are external to the customers. So we are going to talk about all of the outages that is impacting the direct customers, and because of that only the organization are losing their brand image, the finances and everything. And we are going to talk about all of those kind of outages in the overall sessions of InfraThrone Elite. Now, before getting into the next page, apart from outage and blast radius, there is also a technical term that we call as timeline forensics. Now, in every outage, timeline forensics plays a major role. So you need to understand what exactly happens in every minute in an outage. So, for an example, here we have created out a timeline forensics of this Cloudflare outage by our side, that what exactly is happening. Now, it is going to get started from the incident. Let's suppose the incident has been reported at 9:11 a.m. IST. Now, we need to start out the timeline forensics from that time only, and we also need to check what exactly has happened with our infrastructure. Let's suppose a recent deployment, a recent configuration change, or anything that has happened in the past 7 days that is causing out that outage. Now we need to get started with the timeline after that time. Now each of the things that is going to be happen with our infrastructure, we need to write everything down, and this is going to help us understand what exactly happened with our system. And that's why the timeline forensics are a must in every outage. Okay. Now, these are some outage basics. Now, let's now jump into the next part, that is defining out the problem statement correctly. I can see still most of the people, they are not able to define the problem statement correctly in an outage. Let's suppose, for an example, recently I was in an outage scenario where exactly the customers were getting impacted, and few of our internal engineers who have reported out this issue mentioned that our services are down. Okay, that the applications that is expected to serve the customers, they are down, they are not working. Now, if you are a technical person and if you are defining out the problem statement like that in a war room, it is not going to help anyone. Now, you need to understand how to define the problem statement in a very correct way before jumping and solving that outage, right? So instead of saying my services are down, my applications are not working, you need to specifically mention which service is not able to communicate to which service. Now, for an example, our checkout service cannot reach the payment service. Now, again, here we are going to follow the same rule, that is who cannot reach what. A system A is not able to reach out to the system B. This is how you define the problem statement in a war room. Now, moving to the next part, that it is very important to reproduce from the right place. If you are in a war room scenario and if the outage has happened in the production environment, and if you are implementing the solution in order to fix that outage in PPT or development, it is not going to work, because there are a set of outages that happens because of traffic, right? Because of the traffic overload or those kind of thing. And let's suppose, for an example, as I have mentioned here, there is an outage in your production and you are trying to solve it in your local machine by using the port forwarding or anything. So this is not going to work, because each of the time, if you're trying to go for a solution, if you're trying to fix out an outage, you have to make sure that you are solving the outage at the right place. Okay. Now, that is the most important thing, and we are going to understand this all part in detail in our upcoming sessions. So before you are jumping in an outage, you need to understand three different data flow layers. So overall, you need to understand how a user is requesting for a data from an infrastructure, and how a response is being generated from the infrastructure and getting served to the user. If you understand this overall data flow, then it is going to help you understand the normal behavior of the system. And if you understand the normal behavior, you'll be able to find out the abnormal behavior of the system. Okay. So for that, you need to understand three things: the upstream flow, the midstream flow, and the downstream flow. Like in the upstream flow, how exactly the user is requesting for a response, and what kind of infrastructure components are there in the upstream flow. Similarly, on the midstream and the downstream flow. Now, this is how I have created out an example, that from the very scratch, it is getting into the DNS, and then from the DNS, it is looking for the service, if it is existing or not, and then the endpoints, and then it is checking my ports, and then it is checking my application, if my applications are responding or not. And this is the correct way to check component by component. And there is a famous framework that we call as OSI layer, in which we also do the same thing layer by layer. We start from the layer 7, that is the application layer, and we go till the layer 1. Now, the idea of troubleshooting in a war room is always to go layer by layer, to not assume anything, and without validation, you don't have to jump any of those layers. Okay. And when you see something that is off in that infrastructure, make sure to check it, double check it, and then only move to the next layer. Okay. Now, here is one of the common mistakes that I see most of the people do in an outage. They directly get started with the logs. Now, logs are not something that mm, is there that is going to help you get started with or finding out the root cause directly. If you are in a war room scenario, and if you are directly jumping into the logs, it is not going to help you, because logs only show you the interaction between two of those components. Let's suppose I do have a component A, and I do have a component B, and the communication between that A and B is broken. Now, in most of the scenario, logs are not going to expose out the main root cause. It is going to expose out the symptom of the root cause. Okay. Now, if you are in a production outage that has an onion type outage, that means there are too many layers of that outage, and if you are trusting on logs, then it is going to distract you from finding out the main root cause. And that's why we do not directly get started with the logs. Obviously, we have to use out the logs, but not get started with the logs. That is the first thing that you need to understand. Okay. Now, moving to the next part, that is verifying everything and then kill your assumption. Okay. So, if you think, for an example, if you think that your pods are running fine, you don't have to check anything. If you think the service are existing, routing is fine, you don't have to check anything. So, the idea is, if you are going layer by layer in a certain outage where you are not able to find out the solution, you have to verify each of those things. You don't have to assume anything in a outage scenario. If you are assuming anything, I have observed this thing in my whole career, that if we are assuming anything in an outage, that will be the main root cause, and we most of the time think that it cannot be the root cause. So you don't have to assume anything, just go layer by layer, try to verify everything before assuming that. Okay, now here we have categorized some of the failure types. Now, uh, as of now, since this is our foundation week and we need to understand it from the very basic, so these are the four most basic failure types that happens in any production outages. Now, if a service A is not able to find a service B, this is going to be our DNS issue. If a service A is not able to reach out to service B, this is going to be our networking service or endpoint issue in our cluster. If if my deployments are not getting scheduled, it can be the issue of node affinity, resource, or tense, or toleration, anything in this scenario. If my application is broken, it can be the code or the configuration issue that you have set in the infrastructure. So this can be the simple failure types of an outage as of now, since we are just getting started. So if you see that a service B is not able to find service A, this is most probably going to be a DNS issue. Okay, and similarly like that, we have categorized all those kind of issues that happens in Kubernetes. Now in Kubernetes, we have created out all those kind of issues that you can face in control plane, and where to look for as a solution, and then similarly on the data plane. But since this is our first week, so we are going to get started from the very scratch in order to understand uh, uh, the actual troubleshooting, and then we are going to jump on those critical incidents and all. Okay, so here is a few things that you have to do and that you don't have to do. So the first five things or four things that you don't have to do: you do not have to start with the logs, you do not have to restart anything. If you are restarting things blindly, you might erase the evidence from that system. So you don't have to restart anything blindly. You don't have to start with the logs. You don't have to guess anything, and you don't have to jump the layers. Now, as we have understand that in order to fully understand an outage, you need to understand the data flow, how exactly the data is flowing from the user to the infrastructure, and how the infrastructure is generating a response back to the user. Now, in order to understand the whole data flow, you need to understand the overall user journey throughout that infrastructure. And to help you understand that, as I have already mentioned, you need to categorize the upstream, midstream, and the downstream flow. Okay, and you don't have to jump anything; just go step by step. And what are the things that you have to do? First thing is define the problem statement in a very correct way. If you are defining the problem statement in a very off way, it is going to take a long time for you to troubleshoot that outage. But if you are defining the problem statement in a right way, it is going to help you uh, to get that answer or fix of an outage shortly. And then you have to make sure that you are reproducing the problem statement from the right place, not a completely different system. Now you have to trace the data flow, as I have mentioned, and you have to verify the things. Now, here are some of the core rules that you have to understand: define, reproduce, trace, verify. These are the four things as of now that we are going to implement in this outage in order to understand what exactly is happening, and in order to fix this production outage. Define, reproduce, trace, verify. Okay. Now let's jump into this outage in order to understand the details. Okay. So let me zoom this. Okay. So this is an outage, a replication of an actual outage that has happened with Cloudflare in 2019. So it was a root chain issue. So the core issue was something related to that. We have modified the overall outage in order to add some more knowledge in this outage. Okay. So I'll just give you a brief of this problem statement. What exactly is the problem statement? And in order for you to help you navigate through the platform, so here you are going to see the problem statement. And if you want to go through a video view of this problem statement, you just can click on this, and you're going to understand the problem statement from a video point of view. And if you're going to understand from text, you can just scroll down and you will be able to understand everything. And at the very last, we have also attached the timeline forensics, so you just have to click on that and you'll be able to see the timeline forensics of that outage. Here we have attached out the resources for helping you out in order to understand that outage. And then you're going to have 60 minutes in order to find out a solution. And if any of those squads are able to find out the solution, they are going to get 100 points on the platform. Now, within 45 seconds, it is going to replicate this outage in the left hand side, and in the right hand side, you are going to see the problem statement. And if you are stuck anywhere, just click on hints in order to help you out. If you are blocked anywhere and if you do not know where to go for, just click on reveal the hints, and it is going to help you unblocking on that certain area. And these are the resources as I've already mentioned, and this is AI troubleshooting enabled for you. So I'll highly request each of the members of this squad to heavily use this AI troubleshooting. This has all the context of an outage, and it can better help you understand an outage. If you are uncertain about some of those commands to use in an outage, just ask QB, and it is going to help you the same. You just have to also click on this enabling button. Now this is going to scan all the outputs that has been prompted by the command that we are executing, and based on that it is going to help you identify the gaps and all. Okay. This is how you need to move through the platform. And after 60 minutes, if you are able to find out the solution, if you click on submit, it is going to validate your solution. After you submit the right solution, you are going to get the screen of root cause analysis. Just fill out that documentation, and it is going to automatically create out an RCA documentation for you. This is going to be the goal of the session, that everyone will be able to get into the war room and at least try for this outage. Okay. Now, before jumping into it, let's now talk about the details of this outage. So we have named this outage as silent recovery collapse. Now, the name also, if you are aware about few of the outages patterns, then the name is also going to help you in finding out that outage. So try to understand the name, the overall description that we have added for that certain outage. Now, I'll be just okay. So now I'll be just reading it out loud. So here we do have a few of the production microservices that has been deployed in that infrastructure, and one of the microservices are facing the intermediate request failures. Now, all through all the workloads that we have inside the infrastructure are remaining healthy, operational from an infrastructure point of view. And we do have a microservice with the name of backend that is there to serve out the request that is being generated by the user. Okay. And it is actually working very good. Every infrastructure components like the system resources like the CPU, memory, throughput, everything is looking good. The nodes are healthy, the pods are healthy, everything is looking good. And we are facing the uh, intermediate request failures from a user point of view. Now, there are two different microservices that is being deployed in this infrastructure. The first microservice is API gateway pod, which is holding up our backend application, and this second one is the traffic worker. It is just a replica of the customer, so it is generating the request, and those all requests are getting into the API gateway ports, in which we are processing out the request to generate out a response and get back to the traffic worker. This is the whole infrastructure in which we have integrated a few of those elements that you are going to see. But to make things very simple, we have only included two of the microservices, and the first one is the traffic worker, and the second one is the API gateway pods. The first one is responsible to generate the traffic, and the second one is responsible to give you a response. Now, the traffic worker is looking for response from the backend system. And for an example, if it is generating more than 10 requests in a minute, then out of those 10 requests, 5 requests are getting successful, 2 3 requests are getting failed, and 2 3 requests are having the latency issue. So this is an intermediate request failure issue that we have in our whole infrastructure. And now, in order to recover the system, if the system is trying to recover itself, then the impact of outage is actually getting bigger, and more of the requests are getting failed if we are trying to recover out the system. Okay. Now, here is your task to identify why the system is degrading under the failure condition, and you have to restore a stable communication between these two different microservices that I have mentioned. And here is the full scenario, that you are acting as a on-call DevOps engineer responsible for a production namespace hosting an internal application stack. And your application consists of multiple services communicating through an internal service endpoint inside our K cluster. And these are our health checks as of now, that all the workloads are currently running inside that infrastructure. The service endpoints are looking healthy. The DNS resolution is also functioning correctly. There are no infrastructure alerts that has been triggered as of now. The backend application are continuing serving the request. Now, despite all these health checks, everything is looking healthy, but still the customer is bleeding outside those infrastructure components. Now, the platform is still denying a few of the requests, and some of the requests are getting completely failed, and some of the requests they are having latency in it. Okay, so here is the overall situation of this outage, that from a client perspective, from which the users are trying to look for a response, the requests are getting failed. Okay, the response time is increasing second by second, and the users are making multiple attempts in order to complete out a transaction or anything like that. And then this is the overall picture from a traffic worker point of view. And then from our backend application point of view, requests are getting completed, requests are reaching to the application, and responses are successfully getting generated. So there are no crashes from an application point of view. From an application point of view, resources are also overall looking good. So from a backend point of view, the response are getting generated, the applications are working, the systems are working. But from a client perspective, out of 10 requests, 5 of the requests are getting completed, and then 2 3 requests are getting failed, and few of the requests are having the latency issue. Now, to make things very simple in this infrastructure, you only have to focus on the communication part. So there is an issue in the communication of A to B. You just need to fix out that communication that is happening inside the system. Now, let me just help you understand the system wide behavior of this incident. So the platform load is increasing despite the stable usual traffic on our platform. So there is no increase on the external traffic, but still the load is increasing minute by minute. People are trying to recover our system, and this is actually worsening the condition. Scaling the backend replicas is not a solution. It is not improving our stability. Now, infrastructure components are still operational in our overall AWS account, And this is what is happening from a system point of view, from a client point of view, from a backend application point of view. Now your objective is to identify why the platform are behaving like this and why it is unstable as of now, and you have to find out the issue between communication of traffic worker and the backend application, and you have to restore the stable communication, restore the health of those infrastructure, and you have to validate the platform under some of the stress. Okay, now here is the expected outcome and here are some constraints. So you do not have to modify the backend application code, you do not have to remove anything from the code, and you do not have to permanently disable the client communication in order to fix this out. You do not have to depend on increasing or scaling as the primary solution. And here is the expected outcome, that the client request should complete consistently, and overall request volume that is being generated by the client, that should have our stable communication with the backend application, and the communication remains the reliable under any amount of traffic. These are the things, and let's now get into the timeline forensics in order to understand the issue from a timeline point of view. Now, this is going to be a story format of this outage, in which I'm going to explain how this outage from a user point of view, from an engineering manager point of view, that what all action is happening throughout this outage. Now, we have named this outage that the system that wouldn't calm down itself. Now, as I have mentioned that it is a story format, so I'll be going through a story format. Now, this all has begun very quietly. There wasn't any alarms, no red dashboards on our Grafana, and there was just a low priority message in our Slack channel that anyone else able to see a slightly slower response from the backend API. Okay. Now, at the very random time, all of the people in that organization thought it might be an internet issue from their side. Leave it. Okay. Now, from 9:11 IST, this is where all the things have started. So at 9:11 a.m. IST, the latency was increasing, but not enough to alert or to give the pager to the on-call engineer, and not enough to accelerate to the engineering team. Now everything was looking good as of now, but those who are already experienced in an outage, if this kind of things are happening, you should have an idea, or you would be having an idea that what all is happening in your infrastructure. Now, as of now, the pods are running, nodes are stable, the deployments, there was no recent risky deployment that has gone to the production. Everything is looking normal as of now. At 9:15, there were more messages that few more requests are taking much longer time in order to get a response, and those kind of timeouts that was happening occasionally, now it is going to be consistent in a matter of minutes. Okay, now this is what is happening, and at 9:18, you as an on-call engineer, you have jumped in the call, you have run out a simple test. The first call is a success, the second call is slow, the third call now times out. Now you don't see a clear pattern, right? It is happening in a very random way, and you check the traffic, there is no spike in the external traffic, it is looking absolutely good, but still our system is bleeding under the bonnet. Now something is feeling off in our infrastructure, but you don't have that idea as of now. Okay, at 9:25, another engineer points out that CPU is fine, memory is fine, nothing is maxing out, but still we are facing this behavior in our system which is being directly impacting our customers. At 9:27, the log starts filling up, not with errors but with repetitions of retries in our error logs. You scroll and it is just the same throughout our log file. Okay, now at 9:29, you have checked again, but still there wasn't any spike in the traffic, everything was looking normal, but still our system is doing more work than usual. Okay. Now again, the latency has spiked up, and those kind of requests that are occasionally failing, now they are failing more frequently. And internal engineering team is mentioning this thing that we are under heavy traffic, under heavy load. If there is no external load, then you have to think why exactly the system is working more. Okay. Now, here is the timeline from 9:33 to 9:37. From 9:33, there were some of the slower responses, and because of the slower responses, there were more failures, and because of more failures, there were more internal activity and even slower responses. Now we have entered into a loop. So at 9:35, everything is clear that nothing external is driving the system crazy. It The system is not reacting to the external traffic, but it is reacting to itself. Now at 9:37, every component is technically working. The services are responding. The pods are alive. The network paths are fine. Still, our system is doing much more work than usual. Now at 9:39, we have a very quiet room, and the engineering manager has decided that now we have to officially open up the war room. Okay. Now you guys are into the actual war room with your squad, and those who are acting as an incident lead are going to take out the ownership of this incident. They'll be having the ownership to solve it out end to end, and the other folks are supposed to help them solve this out. Okay. Now, here is your mission, that you guys are brought into the scenario as a DevOps, as a on-call DevOps engineer. There are no failing ports, there are no infrastructure alerts, there are no obvious misconfiguration, no clear error message, but still the latency is rising, the failures are increasing, and internal activity is growing time by time. Here are some rules of engagement that you have to follow. You do not have to assume the first symptom as the root cause. Try to dig under the outage, and you do not have to chase only with the logs. You can use the logs as a part of your investigation, but do not rely on logs. Logs are there to divert you, and do not restart blindly. It is going to erase the evidence from the system, and you do not have to assume the external pressure. And these are the things that you have to do. You have to understand the system dynamics, as I have mentioned. Define the problem statement. Do not get started with the log. Understand the data flow, how data is flowing inside the system. Divide upstream, midstream, and downstream, and understand what all is happening. So you are going to have a close to 60 minutes of time, and you are going to lead your squads, and you have to identify the bug, debug it, and verify the fixes, and fix this production outage. After fixing this production outage, you are going to get 15 more minutes in order to create out an RCA. Now, before jumping into a squad-based troubleshooting, let me just give you a walkthrough of the terminal of what all resources are there in our system to help you get familiar with the overall infrastructure. Okay, this is going to take some 40 to 45 seconds. Let me have some water. Okay, I'm sorry, I'm back. So let's now jump into the terminal walkthrough. Let me just. Okay. Now, in order to give you a walkthrough of all the resources that has been deployed in that infrastructure, now before we debug anything, we first have
Saurav,
to understand.
can you zoom in a bit?
Yeah, sure, sure. Thanks. Okay, I hope it is visible to everyone.
Yeah, that's fine.
Okay. Now, before we debug anything, we first have to understand what exists in the system. And we are not looking for problems yet. We are trying to build a mental model here. Okay. Now you have to check what all is deployed here. Now, to check what all is deployed, let me. Okay. So as you can see, that this actually shows us everything running inside the namespace. We are not analyzing issues here, we are just identifying the components. Okay, now just check the pods, just check out the services, the deployments out there, right? Now, since we have seen this, understand this thing that we do have two different microservices: the API gateway, which is acting as our backend service, the traffic worker, which is there to uh, which is basically user facing, and that is generating the traffic. And here are the services that we have. And let's now try to identify the workloads. So for identifying the workloads, these are the workloads that we have. Now let's try to check if this is being assigned to a node or not, as it is in a running condition, so it will be already. But yeah, let's check. Now, as you can see that these pods are running and this has been assigned with an IP. That means everything from an infrastructure is running. And as you can see that we have multiple pods here. Each one represents a running workload out there, right? At the very high level, these workloads have very different responsibility. The API gateway is there to process the request that is being generated by the traffic worker. And the traffic worker is something that is generating the request as an user. Okay. Now, one of the workloads are acting as a service provider, and one workload are generating the activity for the service provider. Okay. Now, let's try to also check out the services here. Now, this service acts as an internal access point. Other components that we have inside the cluster communicate through this internal point. Okay. Now, let's try to also describe any of the service. Let's give this API service. Okay. Now, this actually tells us that how traffic is routed here, which pod received the request when this service is being called, right? And you can see the selector, the endpoints out there, right? And we also have to understand the endpoint. So to get the endpoints, you just have to type the kubectl get endpoints, and if you will hit that, you can see that the endpoints are currently in a healthy situation, and these are the actual pods behind the service. Okay, and when something calls the service, traffic actually lands here on the endpoints. Okay, now let's get one pod. Okay, I'm going to describe one pod. I'm going to describe a traffic worker. Okay, now if you will see the traffic worker, this workload is actually generating the activity inside the system. It is interacting with the service of API gateway that we have seen. Okay, I'll also describe the API gateway here. Okay, now if you'll see, uh, so these are the configuration of the pods that we have set up, and these are the two different workloads that I have already explained. That the one is responsible for generating the traffic, and other is acting as a service provider to serve those requests and provide them the response of that. Okay, now so I would like to mention the workflow here, the data flow here. Now, what exactly is happening? So here is the traffic worker that is generating the traffic. Now this traffic is getting into our service that we have just seen as the API service, and this API service is going to call out our API gateway pods. This is the simplest data flow as of now, in which we do have only three components: the traffic workers generating the traffic, getting into the service, and service is able to find out the endpoint where exactly we have deployed out the resource. After getting into the endpoint, it is getting into the application in order to process that request. And this is what is happening. So this is the basic request flow inside the system. One component initiates the request, another handles the request. Okay. Now let's also see and test out a basic mm, connectivity from our pods. So to check that, I'll just do execute into the traffic worker. So we are going to get into the traffic worker, and uh, we are going to curl the service from here. That is API service. Now, if you see, we here through this, what we are doing, we are just confirming that the communication is possible between those all two different microservices. So we are going to confirm that the communication is possible between those all two logs. And I believe that these are all the system resources that has been deployed in that infrastructure, and this is the basic view of that outage. And since the idea was to clarify the concepts and harden the foundation of an outage, that's why we have included only two microservices as part of our missions that is being going to be assigned in the weekdays. You are going to see the actual Cloudflare outage with more of the microservices involved in it. But as of now, in this session, we are going to focus on the on creating the mental model, and for that, to reduce out the complexity, we have only included two of the microservices here. Now, we now understand the system at a very high level, that there is a service receiving the request. There are the pods behind that service which is processing the request, and there is another workloads that is generating the traffic. Now request actually flows internally within the cluster through this whole path that we have seen. Now that we have understand how the system is supposed to work, let's now observe how it is behaving. And this is what something that we have done through checking out the logs and verifying the connectivity test between the traffic worker and the API gateway pods. Now, the idea is that you cannot debug a system. So if you do not understand the system, you cannot debug a system. And as of now, I believe all the knowledge that is required for you to get into the actual war room has been already transferred. Now you know the system, now you know the logic. Now we are going to get into the war rooms as of now in order to get started with the troubleshooting. So before doing that, we are going to have a minute break, and then in the minute break, you guys can ask questions regarding your squads, if you guys are already assigned to a squad or not. So if anyone who is left and who has no idea about their squad, just raise out your hand and we are going to help you in finding out your squad. Okay, so let's take out six. I'll be just let me integrate out break of work. So I've started out a timer of 1 minute of break, and then we are going to get into the war room. Okay, so I believe it was Sanket. Are we good to go with the breakout rooms?
Yes, we are ready. Just share the screen once we will do how they can start. So
Okay,
please just share the screen.
sure. Just sharing the screen.
Start from dashboard.
Yeah, let me know if you guys are able to see my screen. Okay, yeah, Sanket, go ahead.
Okay, so once you come here and you scroll down, you have the live session. Just up, up, scroll up. Here is a live session. Yes, you need to just join that and your session will start. Right now, like Saurav is part of squad admin. So here you can see there is a crowd in front of my name. So I am the commander and I will be able to operate the terminal. But Saurav has a keyboard in front of him and I am not joined. So he is right now the commander. That's how it works. So now you can like start joining and we will like start the breakout from now.
Okay, now I'll just repeat out the same thing. So if you will land up here in the war zone, you're going to see out a section of live session. Just click on this in order to join the live session. In the right hand side, you're going to see out your squad. And this is my squad name as an admin. I can see that 4 people are in my squad. Okay, and the incident commander is Sanket. But since Sanket hasn't joined out the session yet, so now I am going to be the co-pilot of this incident. Okay, and I can execute out the things right there in my dashboard. After Sanket joins, he is going to have the admin access, and you can also transfer out the access to any of those members of your incident. Okay, squad. Okay, now to join the breakout rooms out there, you what you have to do to join out the breakout rooms, you just have to click on this meeting tools out there, and if you will click into the meeting tools, you just have to click into the breakout rooms out there. Okay, just click out the breakout room, and you are going to see the squad alpha, the squad beta, and the squad gamma. So you guys are you'll be only able to see your squad name here. If you belong to squad alpha, so you are going to see the name of the squad alpha, and what you have to do is to drop from this call and click join here, and you'll be directly transported into the live war room. Okay, so I can see still 14 people are there in the call, so I would highly request everyone to get into their squads, and let's get this started. Hey, hi, Saurav or Sanket. Anyone is there still there?
Yes,
Yeah,
yes.
man.
Okay, so this is like I have already told that I right now I'm still lagging or I'm not able to catch it up. And the thing is like I'm doing my
I think I have that access control to the sessions. Okay. Can you just check if anybody has access or is it just me? I'm not sure. This is the first time I'm seeing this. So I'm not really sure.
Only you have access, I can see.
Okay, Saurav is here.
Uh, just
Sanket, Yash is our commander, but he hasn't joined, so waiting for. Okay.
I think I'm having the controller permission now.
Okay, so just share the screen, Alvin. We'll start.
Are you able to see my screen? Okay, so I have to share. Mm,
oh, I'm sure. Um, I think I still can't have access. You can go ahead.
okay, start. Okay. So I'm pretty new to Kubernetes, so if anybody can just walk me through, I will be really happy. So
Yeah, first.
So before doing anything, just share your things. Just we can proceed, okay? I mean, how you guys approaching and all.
sorry, I was not able to hear.
So before doing, I mean, doing anything, just share your ideas, like how you're approaching the problem statement, and then like
yeah, that would be
I'm not.
fine. Like if you can just describe
Yeah,
that
like
what we are going to do, then it would be easy for us
yeah,
to.
yeah, exactly. And also like I'm very new, so I'm not able to understand like, and even Saurav is doing something like the commands and all, like he's flashing
Okay,
me,
so
Yeah, yeah.
I have an idea. I have an idea. Let's just take
Okay.
1 or 2 minutes and
as Saurav has already described everything, let's just go through it
Yeah, yeah.
once again. So if someone has
Mhm,
just missed any kind of point, they can just review
mhm.
it once again. So let's just take 1 or 2 minutes. And if Alvin, you have already got to know that what the exact problem, you can just go on with that. And once you get any kind of like point to just share us with share it with us, so then we can also know it about. If you are just
Yeah.
leading it right now, correct?
Yeah, sure. So I've checked the uh, ports, and I can see that
Okay.
there are 4 ports currently provisioned here. Once I get API gateway, a traffic worker, 4 DNS,
Yeah.
and local provisioner. And
Okay.
status are all of the ports are in running status now.
Yeah.
And then I've checked the uh, services which are running the cluster, and I can see the API service and Kubernetes service.
Yes.
Okay.
So the API service must be the applications, uh, of the service which is exposing the application. And the other thing we need to check is the endpoints.
Mhm.
So the endpoints are working correct. I hope they are working correctly because it is healthy current.
Yeah, the endpoints are also assigned, have the assigned IP values.
Okay, so Alvin, do you have any like uh, way to just pass out? Like, are we going to do it structure based or layer based?
Uh,
I think we should just come up with the very first point is the DNS.
DNS, right?
We can just execute into the first the traffic pod, execute the traffic pod, and just try to know that how the curl is actually uh, tracing the entire request. Like we can use the curl hyphen b to just get the entire request, and then we can just further execute step by step. We just go into the traffic worker first. Yeah, let's
Not
just try to curl the service first using the hyphen b command.
for hyphen.
API hyphen
It's,
service.
okay, so the endpoints are correctly working, and
Can we start looking at which one is the backend service and which is sending the traffic? Which services are serving the traffic?
I think
I
this
think that's
one, this
what you
one.
say. Yes, yes, that is where the traffic is coming from. What did you say
Um,
about that?
Traffic worker, is that the one?
Yeah,
Yes, yes, yes. That's what is generating the traffic. What were you suggesting again?
So can we, okay, we are already looking at that service, I mean, right?
yes, this is the one.
So there should be some config, which is, okay, this is code.
I think they included that as that is what is supposed to, I think, maybe generate the issues that we are currently that we're experiencing. But we're told not to touch any of those configurations. Yeah, that was what I could make from what you said.
Can we use?
What do you say?
Let's see this. Can you see the screen?
Are you asking if we can see your screen? Okay. Yeah. Okay, you mean yeah.
We can confirm with this.
Yeah, I think we can start with the AI first off, actually. But also, yeah, we could start with that, but also I can suggest that let us even try to maybe make multiple requests to the backend. His own requests was
Can you open the pod in a YAML format? Like, let's see that API gateway. I mean, the issue is, I think the gateway pod is the problem, I believe. But
Did you describe the command shows that there's a delays parameter set? This is something that I think.
Can you do that one, like kubectl get pod and pod name -o YML?
Are you putting it on the chat?
Okay, let's just let me put it down.
How do I call this? Okay.
I'm not able to see the screen.
But we do, I think.
Let me rejoin.
I sent the command in the chat.
Get pod name is no YAML. Okay. Yeah, which pod we want to check?
API get, yeah, API get that. And
what are those numbers? Can you scroll up from the beginning? Like, can you show us?
this looks fine. Wait, here. Delay is 9 seconds. Scroll down a little bit.
Okay, delays present. Does it mean?
And at the same time, which command is taking to get it complete? If we see the timestamp previously, we can
Yeah.
see it took 9 seconds to get it complete.
Correct.
So I think that's what where the QB also mentioned.
Yeah.
So we have
Yeah.
it.
I think a delay parameter is I believe that could be the culprit here.
Probably.
So if we can bring down the time of delay to 0, then
Control
just
C.
stop it.
Control C.
Control C.
Yeah, we'll start with please go NS lookup to see the endpoint.
Yes. Okay. Let's jump it to the DNS part now. We have just completed the client part. Let's go to the DNS part.
We should exec into the app backend server, backend port.
Yeah. Just NS lookup the service. Just do the NS lookup to the service.
No, not from here. From inside the pod. You can do the exec to it.
Just go into the traffic worker part first. Yeah. Okay. Let's dig into the DNS part. Yeah. I got the problem. Maybe the assumption is right. Actually, there is a problem regarding the endnotes, if I'm not wrong. Can we just move into the backend side now?
It's also timing out. Recall the API prompts. What are you trying to do?
Let's try.
Ping. Mm. Mm. Let's try something. Use the curl command that I used with the :80. Yeah, you're unable to ping it. I don't know if ping is enabled by default though. Yeah. I wanted you to explicitly put the HTTP protocol in front of it and not just :80. Yeah, you can try what was sent in the chat just now. Yeah. You could use the service name API service. I don't think the :80 is necessary though. Yeah, API service. Yeah, you can run that. Same thing. Okay, you can try with the :80 that the person suggested just now. We are not getting something right. We can't even replicate the issue.
I think we can ask this QB agent also, right?
Yeah. I agree.
What to ask?
I
That's the
asked,
question.
yeah, I asked it of how we could approach it, and the first thing it said is for us to hold on. Okay, you can ask the question. Let me check what it sent to me just
From
now.
the question, there will be mentioned, right? There is something about the incident might be in 1 or 2 lines. We can pick that up and then we can try to configure it. We can ask that same thing.
So what do we put there?
Question. What is our question? So,
I didn't get what Jamal said though.
there is a current situation, right? You can copy that from the
I hope that solution that we got the root cause. Is everyone okay with that? Do anyone have any questions that there could be any other possibilities to this, or my assumption is wrong or something?
So yes, not a question or doubt, but how do you know it? Like I don't have any idea about that dot and everything.
Actually,
But that-
there was the cases that we have given, like the file labs. Out of that file labs, one was regarding this, where the intermittent failures is actually happening due to the end dots. Like it is less than the number of dots to the query, and it is checking, it is multiplying the real, like multiplying the possible outcomes of the query, and it is where the DNS lookups are getting multiplied, like number of times the end dots. So that was the possible case. So we need to get a solution to this right now. If you are having any kind of doubt, just try to just go and search that why end dots and the search are actual use case to the uh, incident to that particular thing, because I just searched it and I found it that it used to multiply the query number of times the end dot is.
Okay.
Yeah, even I tried looking. Yeah, the same thing is coming up. Yep.
So we got the actual root case. So let's just solve it. Let me just search it on the Google that how can we just solve this particular case. Let me just
Okay, so
give it a
before
second to.
I have a question, like this is my first call. So I'm just trying to
Yeah.
understand, first understand the issue basically. So the clues are
Okay.
there, and you guys were discussing that we can search somewhere, like where we can search .end.
Okay. Okay, I got the thing that you are not understanding. So
Yeah.
let me describe the whole case currently. So it is an intermittent failure, not a continuous failure. Intermittent failures mean a variable failure where requests are getting failed, not to same pattern, but due to some uncertainty into the finding that particular service. So that is the root cause. And if we just dig into the layer to layer, we find that the very first thing is the DNS layer, where actually the service are getting a particular name, or I can say a resolution to a service to its IP. So the very first layer that we described here is the DNS layer. So we just checked into it and found that the dots is getting the root cause because the service is not getting the actual name or actual search. And based on that search, it is not resolving the IP of that particular service. So that is the root cause to that particular problem. So do you have any doubt about it?
Yeah, I mean, this is clear. So we did not assume that the issue is in the DNS layer.
Yeah,
We
yeah, we didn't assume it.
checked.
We just got to it into layer by layer. And
Mhm.
we have just got the clue at the very first layer, which is the DNS.
Okay.
So we are not just digging into the further downstream layers and just try to solve it to the DNS layer first. So if we just solve the DNS layer first, and further we just got to know that the service is the request is also getting failed intermittently after solving the DNS. We can just dig into the further.
right? And this is what is happening.
Hmm. So might be there is some timeout.
It can be. Mhm. You are going in a right direction. Yeah.
Yeah, there's a connection timeout. So probably the connect.
There is a specific timeout is mentioned. Up to that limit, the response should come.
And where do we store the timeout configuration? If it is happening with client, so on the client side, where we are going to store out the configuration of timeout.
I think the traffic pod is there that is generating the load.
So you can check it.
Yeah, go. Can you check there because that described that pod traffic.
What do you want me to check here?
You describe pod, then pod name of the traffic worker node something.
I will do it in YAML.
No, not needed.
Don't do a YAML, just describe it.
Describe spelling you're missing.
Yeah.
So we have total 10 threads probably. And yeah.
Can you give me this describe thing in that pod chat? Or we can see in that terminal, right? Our terminal also.
The cube you mean?
No, we can see also in our terminal. Just let me see.
Yeah. Okay. Yeah, timeout is there. Timeout is set to 10. Sorry, 1. Timeout is set to 1 seconds.
Okay, great. Okay, so if you'll see from the client perspective, the timeout is 1 second, right? But still the request is failing. That means the client is not getting the response under a second, right?
Correct.
So what can be the issue now?
So there is already set 9 second of the delay, and client is trying to get it within 1 second.
Okay, and if you can exactly, so the client is expecting a response within a second, right?
Yes.
As well as there is a delay, right? But
Yes.
how much time a backend is taking to
or itself
Yes, yes, we
We
are
are
the
in
traffic
this
worker.
API gateway.
So no, we need to try it from a traffic worker because it's where we are seeing the issue.
Yeah, you're exec into the traffic worker, right?
No, we are in this.
Oh no, that's not where we should be. No, we are supposed to be on the traffic worker, not the API gateway. I didn't even catch that. Yeah. So you can exit this guy. Oh, oh, yeah, you can just paste. Yeah. Okay, now let's try to, we can start with the port 80 first. Curl http:// API service, and then try to get the response.
Pass on the port and the verbose
Yeah, let's put in port 80, 8080.
in the end.
No, okay, makes sense. The same thing.
Service is resolved.
Yeah, it's resolved, but
Just do Control C again.
It's cannot establish connection.
Just do Control C and Control D again. Control C, Control D. Yeah. Just get all. Right. So the IP of for we need to find the IP of API gateway. So just do a describe for that. Okay, describe.
So it seems the API gateway pod is connected to the API service. Is that okay? You want to directly access the pod itself, yeah?
Yeah.
Okay.
Just hit the tab.
Nothing works with tab.
Okay, it's not picking up. Just do Control W over here. Control W.
What happened?
Oh,
It
that would have
exited.
closed the window.
Yeah.
Yeah.
Screen share stopped.
It
Yeah.
exited from the website.
Yeah, that's what. Yeah, I've experienced that before. Can you try to bring it up again? I hope we do not lose what we have done so far.
At the
Where?
top hand corner, you can see resume lab.
Yeah, cool. What did you want to achieve with the Control W again?
It's a shortcut of Linux where you can just wipe out the whole string rather than doing a back for each word.
Okay, it deletes the whole sentence.
Right.
Why it's not getting copied? What?
Are you unable to paste that?
Nothing's working, by the way.
Maybe as a result of the exits from the other time. Are you able to type anything?
No, nothing's happening.
Resume.
I
I think it's you who has access.
Yeah, the control has gone to you.
To me?
Yeah.
Oh, interesting. Okay.
Yeah. Now you can control it.
Oh, okay, I see. Okay, let me share my screen then. Yeah. Okay. Mm. Okay, can you see my screen? Is it legible?
Yep,
Yeah.
we can see your screen.
All right. All right. Someone was suggesting something before, was that?
Yeah. So
Okay,
have
you
you
wanted us to
have you guys
describe the plot, right?
Sorry, Saurav was saying.
yeah, I was just asking, have you guys found anything yet?
We've been
Mm,
unable to.
Okay.
We tried to even curl the service, but we weren't getting any response at all, both on port 80 and port 8080.
Okay. So let me explain you the problem statement. Okay. Again. So what is happening? We do have a client which is asking for a response from the backend. Okay. And there
Mm-hmm.
is a timeout issue, right? So if you will just get into the hint section and click on reveal the first hint, just click on revealing the first hint. Yeah. And try to read it loud.
The system is failing more as it tries harder. That's no coincidence.
Exactly. So the system is failing as it is trying to get a response, and that's not a coincidence. That means if you are requesting for a response from a server, and if the request is failing, then the system is trying to get or raise another request to get the response back. Now, let's suppose for a user, if I am a user, and if a production system is made in a way that if I'm requesting something and in the first time it is failing, then I'll request it again, right? And if
Yes.
thousands of users are doing the same thing, what exactly is going to happen? It is going to create a retry storm inside the infrastructure,
Yes.
right? And this is what is happening. And that's the step one actually tells you that system is failing and it is trying harder to stabilize. Okay. Now click on step two.
Okay.
This is going to give you a lot of idea. This step two. Okay. Now we'll see failures are
Yes.
happening when response take longer, right? Not randomly. So what happens when a client gives up too early? Try to understand this line. So there is a communication going on between a client and the backend. Okay. And client are requesting for data from the backend. And if uh, the responses are taking longer, then only the failures are happening. And the client is not ready to give up. Client is
Okay.
saying this thing that I will still try. I will still try. And
Yeah.
where do
Should
we
there
store?
be?
Mhm.
I
Go
was
ahead,
going to
sir.
ask if there should be some sort of maybe back off something. I don't
Uh-huh.
know, so that the
Where do we
risk,
store the
the
backup?
request. What did
Mhm.
you say?
Yeah, I was just asking, where do we store the back of configuration and
Yeah,
everything?
I saw it in the deployment file of the traffic pod.
So
You,
if you can describe the deployment file again.
hmm,
Okay. You are actually checking the configuration of the backend. Okay. The issue is happening with client again.
oh yeah, that's correct. Yeah, yeah, yeah. Yeah.
So
Traffic
if the
walker.
issue is happening with client, why you are checking with the application? So let's check with
Yeah,
the
yeah, that's
okay.
traffic walker. Yeah. Yeah. I
You
missed out.
press the P. Yeah. Yeah.
Yeah.
Okay. Now, where exactly you
Yeah.
have configuration?
This, yeah.
Okay. Now, Try to understand these all four variables that has been set as an environment variable. The timeout,
Yeah.
1 second, right? What exactly is the value? What exactly is the concept of a timeout?
How long before a request is returned as a time is
Timeout.
how long it takes for a request before it times out?
Okay.
I guess the value is minute is second.
Exactly. And what is the concept of threats?
The total number of concurrent requests. I guess maybe every request carries 10, how's that said?
Mhm.
A single request comes as 10 requests. I'm not putting that correctly.
Right,
But
right,
it
right.
is,
Hmm. You got it
yeah,
right.
it is, yes, it is. Um, I don't have the right word, but a single request comes in as 10,
Yeah.
basically. Yeah,
Correct.
similar to what is
And
used to
then we
overload
do
the system.
back off and rate control, right? So
Yes, yes,
the
yes.
the client is expecting a response in a second. Okay.
Yes.
And something is happening because of that, it is getting a retry or timeout error. Then what it can be? Try to collect the pieces out there. Okay. The client is looking for response under a second, and
Yes.
the threads are 10. That means the client can amplify the number of requests.
That's the word amplify. Yes,
Yeah.
yes, yes. A
What
single
it
request
can
is amplified 10 times.
exactly. So what it can happen? It will result you out in a retry from outage, right?
Yes,
Now
yes,
you need to
yes.
understand the behavior of the application, how the application is behaving. So if you will get into the application configuration, they will try to understand this.
The application configuration, which
Mhm.
is that?
The API gateway pods.
Okay, okay.
I hope you got the context, right?
Yes.
How we are
Yeah,
trying to connect out the dots. Now the issue was simply that we do have A and B, and A is trying to communicate to B, and you are facing timeout errors, right? A has a configuration that A is expecting the response within a second, and A has the superpower to amplify the request into 10 threads. That means A will be generating much more requests in every second, right? Now we have to understand, is our backend capable of handling all those requests and capable of responding the request and generating the response within a second?
I can see delay 9 here,
Uh-huh.
meaning it is taking its time before it responds. And on the other end, the front end or the traffic generator expects a response within 1 second. So ultimately, there is going to be a delay between how long the backend can respond and how soon the front end how soon the client expects the response, or the traffic generator expects the response. So the backend is not configured for that level of response. Also, the number of threads on the front end, meaning 10, it is basically overwhelming the backend service, and it is not even giving it space to breathe.
Mm-hmm.
I hope
Exactly.
I'm
You
correct.
got it right. So if you'll see what exactly is happening, that I am trying to communicate with Fee, okay, and I'm expecting a message back in a second, and Fee
Yes.
is going to take 9 seconds in order to respond me back. But while waiting for a second, if I'm not getting the response back, I'll be hitting down another message. So I'll be
Yeah.
generating 9 messages until Fee respond for one message. And through this, I'll be generating much more messages, and Fee will not able to handle all the messages,
Yes.
right?
Yes.
This is what
Yes.
is happening, right?
So the issue
Yes.
is with pod A, right? We just have to increase the timeout.
Now, that's not very simple. Again, this is where the engineering actually comes into the picture. This was the layer one. Okay. Now, here is the engineering part, that if you have a production application, okay, how to set the back of value, how to set the delay value, how to set the timeout value, how to set the latency values. For that, you need to understand. Let's suppose I have an application, and if I'm expecting 10,000 of traffic in a minute, in 60 seconds, I'm expecting 10,000 of requests. Okay. Now, I'll be configuring my values of back off, jitter, latency, all this according to that 10,000, right? So, how to calculate the right value of those environment variables? Now, if you understand latency, there are three kind of latencies out there. Uh, the first one is a P95, the second one is P99 and P90. It is more like an average case, best case, and a worst case. Now you have to calculate the values of all these environment variables in a very accurate manner. So you can ask QB that how to understand the right values of all these variables in a production. I hope this makes sense for everyone, right?
Yes, it does.
Yes.
The prompt for QB again, you said we should ask it how to rightly calculate the backup value and
No, no.
what's that again?
This is where you have to understand that.
Now it is updated. Now check the logs. Super.
Now it's
That is it. Then submit it. I think we are getting response. Check the first. Check that one and that K that curl command we use, right? This one. Enter. Oh, that pod name. Fine. Now 9 seconds. Yeah. Okay. Submit this. I think we got the response.
is that the one? So basically, it's the timeout. But how do we determine value?
See, that's okay. So basically, 10 threads are going.
Yeah.
Okay. So we are telling the system only one request should go at a time. I mean, per second. Okay. And we are providing the timeout 10. That means that it will check for 10 seconds in overall system because we already put 9 seconds in the app side, right? So that it could get the response within that time frame. So that's why we put the 10 timeout. Okay.
What does the rate control value do or parameter do?
Rate control will one request per second. So only one request could go there.
Okay.
Okay, not the 10 one because threads are 10, right? So it can go 10 threads. So as the hint was saying that if you generate more load, it will fail more. So that is why we are reducing the load to one and only one request could go. It get the response within that 10 second of timeout, then second request will go again. Okay, now try to submit it. I don't think that.
Do you think like we ask validate it once and then submit?
So how do we validate without
I think
submitting?
we can ask for help, right? There's something called.
Okay.
I see Saurav is here. Saurav? What is it, Sanket? I don't know. Yeah, Sanket, is it the right way that we submitted or? Okay.
So once it submit, then only will it get to do.
But if you are, is it not correct?
Oh, okay, yes. Okay.
Okay, I just looked at the thing, but yeah.
Okay, I am chatting with Yes, and I am asking Yash about some updates on my Discord messaging channel. Okay, so I'm just asking him the update, and I am expecting a response within an allowed time, and Yash is actually taking much more time to give me a response back. In I'm having curiosity to know the answer, so I'm just messaging him again to get a response back. And until Yash responds me back, I have messaged close to 6 or 7 messages till now. What is exactly is happening, that me as a client, I'm not trying to give up enough to get a response, and Yash is taking some time to get generate a response. Now, out of this story, that the step 2 tells, what you understand, where do we set these all configurations? So it is a behavior of applications, right? So I as a client is behaving in a way that I'm expecting a response in a minimal time, and Yash as an application is behaving in a way that it has a capacity to generate out a response in a specific time, right? So there is something not right in between that communication. So where do we have all the configuration of this all communication?
Okay. Like
Mainly at the
suppose
DNS level, that resolution is actually getting tested.
I'm sorry, what I missed it. If anyone can go again.
you told about the DNS resolution part.
No, no, DNS again. You are going in a very wrong direction, as the problem statement already mentioned that DNS is looking good, and that's why it is able to discover out other things inside the infrastructure. Now, if you have checked out the logs, if you understand the pattern, if you understand the question statement, there's a communication issue, right? And as the steps revealed that our A service is trying to communicate with the B service, right? And the A service is expecting a response in some time in which it is not getting the response, and the A service is actually trying more to get the response, and this whole thing is causing a retry storm in my infrastructure, and this is why the system is doing much more work than the usual time, right? So where do we store this all configuration?
Core DNS. Oh, okay.
Exactly in the code DNS, yeah. So in
Uh,
Mhm.
sorry, sorry. I will.
Good, good.
Yeah, sorry. Like what I have understood is you're saying that it was. I mean, for example, from front end, if we're trying to call an API, we are not getting response in X milliseconds of time. It's going to retry.
Right. Mhm.
So the developer have wrote the logic. If you're not getting response in X milliseconds, you have to give retry continuously. So this is what's causing the issue.
Exactly. So in our application file, we also store the same thing. In the infrastructure or in the application file or in the infrastructure, from an infrastructure point of view, we have to mention all this configuration into our deployment file, right? So if you can check out the deployment file configuration step by step and try to understand what exactly is causing this all issue. So if you list down the pods, and if you can actually check the configuration. So I'm asking this question that where do we store the behavior of this communication? Again, I believe you are checking out the API ports. The issue is something that is happening from a client side, right? The client is facing issue. The problem statement already mentioned this thing that the backend is working absolutely fine, right? So you first have to check out the configuration of the client in order to understand the behavior.
Uh, Saurabh, maybe it's a caching problem
So
where
if it
client
was
is actually caching the
Mhm.
possibly client is caching the same response like wherever it is actually hitting the request, it is just caching into it, and the cache duration is much larger than what it expect to.
In the environment, we have the timeout as one, right? So that is the thing.
Okay. And what exactly is the meaning of a timeout? If you can
Like,
help with that.
yeah, so it means that in that specified time, that is 1 second, if it's not getting the response, it will time out and give us the error.
And what is the error that you are getting?
But timeout failure, something like that was there in the log.
Mhm.
Retry,
Exactly.
timeout, something.
Okay.
And
Now,
in
if you
in
will,
the other pod, I think the timeout or the value is 9. I think there.
okay. So if I am expecting a response in 1 second, and if you are generating 9 seconds to give a response, this is what will happen.
Failure.
Okay, it would get fail.
That is the first layer. Okay. That is the first layer of this outage. We'll scroll down to those four environment variables out there. Now, I want you guys to help me understand these all four different variables out there: timeout, threads, backoff, and rate control.
Okay, so the timeout is basically any request that how long it is going to remain. That if it takes more than particular time, it is going to get a timeout and pass the status that it has failed. This back off is basically retrying after a certain period of time.
And what exactly is threads out there?
The number of threads. Uh,
Number of requests simultaneously, maybe.
Exactly. So it is a concurrent request. Now, I am a client and I'm expecting a response in 1 second, and the backend application is not capable of generating out the response in 1 second. It will time out.
Yeah.
If I have threads into 10, then what it is going to do, it is going to amplify the request that I am generating as a client. And then it is going to get into that retry storm. This is what is happening. Now the question is how to set the right values of all these variables that you are seeing on the screen. How to set out the right value of timeout.
Maybe we need to check the behavior of the client. Basis of
Exactly.
that, we need to.
Absolutely right. Now, if I'm an application expecting 10,000 of traffic in 60 seconds, so according to 10,000 of traffic, I'll be calculating my latency values. Now, in latency, I do have three kind of latencies out there: P95, P90, and P99. It is more like a best case, worst case, and average case scenario. Okay, so I'll be calculating the exact values, and then based on that, I'll be having a jitter time with the back off, and then I'll be calculating each of the values and integrating in the application. Now here is the main question: how to calculate the right values of all these variables in your production application. Now if you are deploying out a production application, you need to understand how to set the right values of all of these variables into your production, and for that you can use out QB out there.
Okay. Well, we just see the client configuration. Maybe there is some values that
Yeah,
not
yeah.
on basis of which we need to define these values.
Exactly. This is the client value, by the way. And the second one is the application value.
So, this is the client values.
Buildouts.
Just copy it.
Rather, we should use ping is working, but telnet should be checked.
But what?
Instead of ping should work. No, it's not.
It doesn't appear to work.
Can we check the logs once? All logs? Earlier person has request timeout something. Let's see what it is showing now.
So we're checking the logs of the
Traffic worker.
traffic worker. Okay.
You need to come out of that container, I guess, right? You're in the container.
No, I'm out of the container already. I'm trying to get the pod.
It's here. The third one.
Okay.
-F.
Yeah. Yeah, it's working fine. But why can't we curl? Should we just submit?
Yeah, we don't have time.
Even though we're unable to replicate. What do you say? Should we submit before time goes off? At least we are getting a status 200 now.
Yeah, we can try again.
Okay. I guess so. The session is okay. This way. Okay. Oh, you think so? But we still have some seconds. Goodness. Oh, goodness. Okay. Should we end it and just go back to, or should we try to redo it?
Let it provision.
I was fairly certain I clicked on the submit button.
Guys, we are already out of time, so let's try to join the main call. Okay.
Okay. All right.
Yeah.
Let's get into it. Okay.
Okay.
So we need to adjust everything, but no idea how to do it.
Guys, we are already out of time, so let's try to join out the main call. You can just click on joining out the main call and you will be redirected to the main call. The whole team is waiting there. Okay. You have a timer of 30 seconds to join that. See you. Okay, we have close to 18 people. I guess few of the people are still in the war rooms. Sanket, if you can check with them. Okay. So let's do one thing. Let's have a 2 minute of break. I'll be just attaching out a timer in it. So I guess it has been 2 straight hours. So let's take 2 to 3 minutes of break. and then we are going to reiterate on at least having a discussion of the experiences of different squad, and then we are going to wrap the session by today, and rest of the session we are going to continue tomorrow in order to understand the troubleshooting step by step, the solution, and building out those resilient systems that we were talking about. So I'm just integrating a timer of Sanket. You have already started a timer? Yeah. Okay. I'm not able to edit it from my end. If you can, yeah, have a timer of 3 minutes at least. Okay. See you guys in the next 3 minutes. Okay, so I hope everyone is back. If I can get a thumbs up. Okay, I can see most of the people are back. So let's start our discussion. So we were having three different squads, the squad alpha, beta, and gamma. So I'd request everyone to switch on their camera if they can. And let's try to have a discussion over this. And this is going to be the most important part, where exactly we are going to learn from other experiences. So everyone was actually trying a different approach. So the problem statement that we were having, everyone was taking out different route to solve it, and most of the people have got the issue. And it was not a layered issue; it was a single layer issue, and we are going to talk about it. So I guess we have three squads, so I'll request the squad owners, the incident commanders, to share their experiences of what was the outage they think, and what kind of solution they have implemented. And the third is handling out a team from a leadership point of view. So I want the squad owners to answer these three different questions: what was the outage, what was the fix, and how they handled their team. So we can get started with the squad alpha. So I believe from squad alpha, if you can let me know who was the owner of the squad alpha. Sanket, if you can let me know the owner of squad alpha.
Okay, I think I'll go for squad alpha, I guess.
Sure. Yeah.
Yeah. So what was the question again, please?
Yeah. So the question was that I guess you were in the squad alpha, right?
Yes, I was.
Okay. So we have almost spent an hour in the troubleshooting. So I want you to share your experience in terms of what was the outage, how you approach the outage, how you find the solution, and then how you handle the team in terms of the leadership.
Okay. So okay, first things first, we tried to understand what the problem was. We tried to access the traffic pod to see, just to try to replay the same issue again. And when we did, for some reason, we were unable to curl the backend service. We tried to curl both on port 80 and port 8080, but we were unable to access the backend service. So we then tried to take a look at the deployment file, at the deployment file of the traffic service. And at the first glance, one thing that jumped at us was okay, we first noticed the, what's it called? The backoff that was set, some environmental variables that were set there basically, but we didn't really make much of it. We then attempted to retry to access the backend service again, but we still could not access it. Eventually, we got to make use of the hints, and then that then drew our attention to the timeout that was set to a second, and the thread that was set to 10, meaning that the traffic is going to wait for a maximum of 1 second to expect response from the backend service, and every single request is going to be amplified 10 times based on the thread that was set, meaning that there is an exponential growth in the request to the backend. We then took a look at the configuration of the backend service itself, and we realized that it had a delay of 9 seconds, meaning that the backend service is going to wait for at least a minimum of 9 seconds before it responds. That means that there is an inconsistency between how long it takes the backend to respond to a single service and how soon the front end expects a response. And then the total number of response sent by the front end is going to be amplified by 10, meaning if you send 2 response, that's going to be 20. If you take the back end, about like maybe 180 seconds to respond in total. What we tried to do to resolve the whole thing, to shorten time, was that we tried to configure the environmental variables on the traffic side, meaning we set the timeout to 10 seconds, meaning it is going to be at least greater than the delay on the back end, so that even though the backend takes 10 seconds and takes 9 seconds, at least there is like a 1 minute breathing room, or 1 second more for the traffic side to hold on for a response from the backend. Also, we set the thread to 1, meaning that a single response is going to have 1 response in the true sense and not 10 or not multiple responses. We set the back off to 3 seconds, meaning that even in the case of a failed response from the backend, it doesn't immediately try to retry. There is going to be a 3 second delay before it retries again. Unlike before, where it was set to 0, which kept the loop on to keep on going. And then we set the rate limit to a second, meaning even in the case of a successful response, it doesn't just retry to send a second. It doesn't retry sending a response, a request again. It's going to wait for at least 1 second. We set that to 1 second. So it's going to wait for 1 second after a successful response before it then tries again. After applying this on the deployment file, we restarted. We saw that the pod had already restarted, and then we took a look at the logs of the
I guess we lost you, people.
of the traffic generator, and we saw that we were getting a state of 200. So that was what we observed or how we worked. Can you hear me? I think I lost. Hi, can anyone hear me?
We can hear you now.
Okay, yeah, that was, okay, yes. So that was how we walked through it from the beginning down to the end up until when we were able to resolve it. I hope that answers your question.
Absolutely, absolutely. That answers in detail. Now, I want one more perspective from you. How you handled your team. So I was able to see that there are close to 7 people in your team, and most of the people were contributing in the troubleshooting. That was not the exact case in the other squad. So how you have managed the team in terms of leadership and all?
So yeah, the team did a great job by coming up with ideas, and every idea was taken into cognizance. So okay, first off, when we're trying to, yes, that's correct. Jamal was put in as the commander. If you would like to talk, that's fine. Was put in as the commander, but so yeah, everybody came up with good ideas, and we tried to implement them. For instance, when we were having difficulty accessing the backend service, we tried on port 80, we didn't get a response. When we checked the endpoint, we saw that it was attached to port 8080. We tried to curl on port 80. Someone suggested we tried on port 8080, still no response as well. But we kept on getting ideas from other engineers on the team. Also, at the point where we were trying to edit the YAML file to change the environmental variables, we were trying to configure it, or I was trying to configure it on the pod, but apparently that's not going to trigger a restart of the pods. So someone gave the bright idea of implementing it on the deployment file. So we implemented it on that, and then that triggered a restart of the pod. And then we saw the success, a status 200 okay when we checked the log of the traffic worker. So yeah, everybody came up with ideas, and we were able to put them into cognizance as well.
Great. And I guess squad Alpha was the fastest squad who has taken out different route, but at last they have submitted out the right solution. But again, on the squad Alpha solution that they have submitted, there was a lag between the expected solution versus the delivered solution, and we are going to talk about that engineering detail on how to set out the values in a very right way, because the values that they have actually came up with, that was a escape value. That was not the production actual values that we have to embed in the application. So we are going to talk about the values and how to set all this in our application. So make sure nothing similar like happens in our production applications. Now moving to the squad beta, I guess squad beta was led by, yeah.
Excuse me, please. So before I move to squad beta, when we were trying to submit, for some reason I don't think we were able to. Did you see our submission?
Yeah. I can see your submission.
Oh, okay. Awesome. Oh, all right. Thank you very much. Okay, that's all. Thank you very
much. Okay. Now moving to the squad beta, I guess Kareem was leading squad beta, right?
I was not the leader actually. I think I was just
okay. But if you guys can help me with those all 3 questions of what was the outage, how you figured it out, and how you approached that, and at last closing it with a leadership point of view. So if anyone from squad beta, Deepak, Karim, or anyone who has worked there if they can share their opinions on that.
So basically, we first check that traffic flow from the traffic worker pod and the app gateway pod. So there we check what is the curl response time, and we saw that 9.03 seconds or something like that. So then we check from the API service of that pod, and then we check curl that traffic gate that one from traffic gateway to that API service. So it was a response of 9.03. Then we check that what is the timeout value set in that backend application. Then we saw that there is a delay of 9 seconds. So as we try to modify that delay to 0 second so that it can get the response. But once we use the AI that tool, and it was saying that we don't need to modify. You don't need to modify the backend application. You can only modify, like, you don't have that. This is not a right approach. Then we went to that traffic one where the actual traffic is coming from that pod, and then we saw that there is a timeout 1 second is mentioned, and the red control and backup is 0 0 second, and thread is 10. So we saw that 1 second is there. So within 1 second, the traffic is trying to get the response, but there is a delay in the backend application of 9 seconds. So there is a complete mismatch on this between this request and response. So what we did, firstly, we were trying to calculate that what could be the exact value so that it can satisfy the condition. So we went for that 10 second of timeout because already there is a delay of 9 seconds in the backend application, and we proceed with the process. Thread is 10 and backoff is 1, and that another parameter is 1 backoff, and I think I forgot that name, that one, another one. So that we mentioned it, but we try to submit that one, but it was not expected. But there is a certain value we need to always maintain. I saw that there is a red like thread. It should have more than 5 and equal to 5. Also, the timeout value was the perfect one, the 10 one. Then we saw that the red then we tried with that 5 value with the red control 1, okay, and backup of 1 second. Then again we submitted it, then it was again failed. So there was a error, like details of that validation, that the backup should be point I mean 0.5 or something like that. Then we try to change the value again, and then we proceed with that like parameter value, and then we submitted it. Then it went success.
Correct. But again, the solution that you have submitted from the beta squad, no? If you see the values that you have submitted and the logic behind creating or submitting out that values is not that absolute, okay? And I guess every squad was exactly lagging that point. So we are going to talk about that in detail. And if you can also help me with that leadership point, since in this squad beta, I felt that there was not that much of engagement by all of the people. I see only Kareem, Deepak were involved in the communication. So if you can also help me understand the behavior of your squad.
So I actually don't know that about that other. So I feel that maybe there are many person who are coming fresh, like in this environment. Also, we don't have idea about this environment. Firstly, we were discussing 10 to 15 minutes. We just wasted for to understand what is this, like how can we proceed with that. Okay, basically. So yeah,
Correct.
maybe because of the first call, then it was not there.
Correct. Correct. Okay, let's now move to the squad Gamma. I guess that is the final squad, and squad Gamma was actually taking a very different approach. They were talking more about the DNA stuff. So, anyone from squad Gamma who wants to go next? I can see from squad Gamma we have Yeah, if you are there, Yash.
Yeah. So first of all, let me just apologize with the actual that I just let it into a very different solution because I was assuming that it was the actual cause, and I just missed the very first point, which is the client side, and I approached it completely to the DNS part because I had like a scenario based on it, and that was the only reason that I thought that this could be the particular issue. But I missed the part that actually other leaders or other teams just got into that. First, we need to check that whether the application side or the client side is actually working properly, and a request is being handled or requested are getting back the response in a particular delayed second or time. We actually missed the complete scenario, and that was the first time I was leading, and though I am not experienced in this field, now I'm just a freshman to it, but I just tried to just evaluate whatever things that I had and whatever exposure that I had from that particular thing. So yeah, it was a
It was good. That was
like
absolutely
a
good.
very
And since that was the first call, okay. So no worries on that. But I believe the missed part was actually you guys haven't actually understand the question, and you guys have jumped into the solution, and because of that only you have taken out a very different approach, right? And
yeah.
everyone was actually thinking in that way only. So I when I have joined that call, so everyone is only talking about core DNS. So the core problem statement, no, you guys have shifted the core problem statement into a different direction, and that was because of not understanding the problem statement or going through the problem statement again and again and directly jumping into it. And again, if you are acting as a leader and owner of your squad, and if you are giving a direction to a problem statement that we want to go and approach in this direction, then your whole squad is going to follow the same thing. And this is the problem that has happened with squad gamma. Okay, so I believe that in squad gamma there were 3 to 4 people who were actually interacting with each other. So they were talking about a single point of failure, and in any outage you don't have to assume anything. So you first have to understand the situation, the system, and then you have to talk about all those things. And the basic part we have completely missed out here, and that's absolutely okay because this is our first session and we are trying to establish the foundation out here. Okay, so no worries on that. And I guess that was mostly it about this call. Okay, we have understood all this problem statement. In tomorrow's session we are going to talk about the approach that you should have taken in a very ideal situation, right? Now, if this is the week one and the amount of time that has been taken by every squad is close to 60 minutes, that's completely okay. But if it is the same situation till the week 8, then it is something that we have to worry about, because if it is the actual production, then each and every second is going to matter. And spending 60 minutes on thinking this kind of scenario, that can actually cost a lot to an organization. Okay, so we are going to develop that mental model, that instant that you need in every troubleshooting. And since we are just in a phase of establishing out the foundation, it can happen, and it will happen in the second week also. But you are going to see a change from the third week, that you are actually seeing the problem statement in a very a different approach, in the right approach. Okay, so in tomorrow's call we are going to talk about the approach, the right approach, how to set the right values, how to create out a sustainable system that can avoid this kind of outages in your infrastructure. And then at last we are going to talk about RCAs. So I believe everyone now has a understanding of what was the outage. Now I want everyone to go ahead and give it a try one more time, okay, and create out an RCA out of it. And in tomorrow's call, we are also going to talk about how to create out a perfect RCA. What kind of 5 whys are there in an RCA and why RCA is important. And we are also going to see a bad RCA example. And at last, we are going to conclude this problem statement with the actual problem statement. So this was the layer one of this outage. We have created out a full outage of Cloudflare. Now, since you have the idea of the actual core root cause, now you can get into the those kind of variations of this outage to try it out. And this is the category of outage that we call as cascading failures. Okay, so we are going to assign 5 to 7 more outages as a mandatory exercise in the next week, and you are going to perform the same thing in order to stay confident. If you face any kind of issues like that, you should have that instant that, yeah, I know this can be the overall root cause, and I can clear this up in a minute or maybe 10 minutes. Okay, so this is something that we are going to execute tomorrow. And in tomorrow's session, we are also going to ask you for your availability for Monday's on call. So on Monday, we are going to have our rotational on call. So in your squad, you are going to attend out this overall on call. Okay, and you can opt as an individual also. So the idea is now we have also integrated a pager in the system. So you can choose out your shift as 4 hours or 48 hours or 24 hours anytime according to your availability, and you don't have to stay with the system. You are going to get out a call when exactly if anything is going off in the infrastructure. You are going to get a call from that infrastructure that this part is not working, and you have to get in the call in order to sort this out. And then as soon as you solve that part in that on call, you are going to get into the layer 2. So in every on call, we can expect close to 7 to 8 outages. Everyone on the call is going to experience the same outage but in a different way. So you are going to get into the same outage, same infrastructure, but that infrastructure is going to break in 48 or 90 different ways, and you are going to experience those all different ways on the on call. Okay, and this is something that we are starting from Monday onwards. So we are going to circulate a Google form in order to ask you for your availability, and then based on that, we'll be getting started with on call. And I believe that was it from my side regarding this session. And after the session, make sure to give it a second try on this lab and try to create out an RCA. And then in tomorrow's call, we are going to restart on this problem statement. So yeah, thanks a lot everyone for joining on the session, and see you guys tomorrow. And yeah.